This video is on evaluating absolute value expressions. An absolute value expression is an algebraic expression that lies between absolute value bars. The absolute value of a number is its distance from 0 on the number line. Since distance is always positive, taking the absolute value of a number basically makes it positive. So here's an example. The absolute value of -4 is how far -4 is from 0 on the number line, and that distance from -4 to 0 is 4 units. So the absolute value of -4 is equal to 4. The absolute value of +4 means how far is +4 from 0 on the number line, and that's 4 units. So the absolute value of +4 is a +4. When evaluating an absolute value expression, we want to treat the absolute value bars as grouping symbols. That is, we want to use the order of operations to evaluate the expression that's between the bars. So you come up with one number between the bars and then take the absolute value of that number. So let's do several examples here. So we need to evaluate each expression. Here we have 3 minus the absolute value of 6 minus 4 to the second power. So I need to do order of operations between the bars first. I notice I have subtraction and I have a power, so I need to evaluate that power, that exponent first. So this is going to give me 3 minus the absolute value of 6 minus 16. Okay, keep going. I'm shooting for having one number between the bars there. So it's going to be 3 minus the absolute value of 6 minus 16 is -10. Now that I have just one number between the absolute value bars, now I take the absolute value of that. So the absolute value of -10 is a +10, so this turns into 3 minus 10. Just 3 minus, this turns into a 10, which gives me my final answer of -7. Let's take a look at our second example here. We have 4 minus 5 times, remember this is going to be multiplication, 5 times -12 divided by the absolute value of -12 divided by 2. We do not want to distribute over the absolute value bars. We want to simplify, use order of operations between the absolute value bars first. So I'm going to have -4 minus 5 times the absolute value of -12 divided by 2 is -6. Okay, now be careful. Resist the temptation to do -4 minus 5 because that's going to be subtraction. I need to deal with this multiplication before I do that. But even before that, I need to deal with the absolute value of -6. So I have -4 minus 5 times, and I'm just going to switch to parentheses here because I like to use parentheses for multiplication. The absolute value of -6 is a +6. So this is going to turn into -4 minus 5 times 6 is 30. I have to do my multiplication first. And that's going to give me a -34 as my final answer. Okay, so once again we simplified within the bars and came up with one number between the absolute value bars and then took the absolute value of that. Here's an example where we have to substitute in a value. We have 23 minus the absolute value of 3 minus 4x if x is equal to 2. So my first step is going to be to substitute in 2 for x. So 23 minus the absolute value of 3 minus 4 times 2 and the absolute value bars. One thing about absolute value bars is make them plenty big so you don't think that they're ones. Okay, so I need to simplify between the absolute value bars. So in there I have 3 minus 4 times 2. I have to do my multiplication first. 4 times 2 is 8. That's going to be equal to 23, and I'm still continuing to come up with just one number between the bars. 3 minus 8 is -5. Now that I have one number between the absolute value bars, I can take the absolute value of -5, which is 5. So 23 minus the absolute value of -5, which is 5. And 23 minus 5 is 18. And my last example here is 4a minus the absolute value of 3b minus 2c if a is -2, b is -3, and c is 2. Lots of negative numbers here, so let's go ahead and substitute those in. So 4 times -2 minus the absolute value of 3 times negative 3 minus 2 times 2. Whenever I'm doing problems where I have to plug in values for my variables, I always go back and check and make sure that I got everything right. So A is negative 2, B is negative 3, and C is 2. Perfect. Now we just need to use order of operations. I can go ahead and do this 4 times negative 2 outside the bars because that's not affected by what's between the absolute value bars. Now let's go ahead and use order of operations between the absolute value bars. So I have multiplication, subtraction, and another multiplication. So I can do negative 9 minus, I can go ahead and do 2 times 2, which is 4. Okay, now I can do that subtraction. Negative 8 minus the absolute value of negative 13. Okay, don't turn these positive. Wait until you have one number in between the bars and then you can make it positive. So that's going to give me negative 8 minus the absolute value of negative 13, which is a positive 13, and negative 8 minus 13 is negative 21. So in this video we took a look at how to evaluate an absolute value expression and talked a little bit about what absolute value actually means in terms of distance from 0 on the number line. And we emphasize the point that if you are evaluating an absolute value expression, you want to use the order of operations to come up with one value between the absolute value bars before taking the absolute value and then finishing any addition or subtraction that you need to do.